it's out this many days for being sick, so I'm trying to push through it. So I appreciate you guys to kind of hold out here. Again, these guys today are going to be the other parallelograms we look at in terms of what we call the family tree. As you guys know, when you what is it? Genome, species, something or other. Is that right?
Kingdom, phylum, it's king. Who remembers the little sayings that you remember the order and signs when they're classifying the kingdoms? Kingdom, phylum. There's a little saying like.
There's something like that, but think of like you got great grandpa, grandma, grandpa, dad, son, all that family tree. You all have the traits of what's above you, that kind of stuff. So that's what we're looking at here today. We're going to talk about what we call the family tree. So what we did on Monday is we talked about parallelograms. And in parallelograms, they all had the same properties. We all know that they had opposite sides, obviously parallel, opposite sides congruent, opposite angles congruent, excuse me, consecutive angles that are next to each other. Oops. Supplementary. What does supplementary mean again? Lady, good. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. And then the last little bit that we did on there was the diagonals bisect each other. Okay? And that was the same for every single parallelogram. All right? As we get more specific into the shapes, when we start looking at rectangles, rhombuses, and squares, each one of those shapes carries the parts of the parallelogram and then more specific pieces. Okay? So as you get into these things, you're just still using all the same here, but we're adding a couple more parts. Things that you guys already know because, you've all gone through elementary school, and I know all these shapes around the walls of the elementary school with all the pictures of all the shapes of the walls of elementary schools. So this isn't going to be anything different. Different pieces it will be every once in a while. You have a little bit of the algebra thrown in to solve for x, that kind of stuff. So we bring off the offshoot here. We talk about, first we'll talk about the rhombus. You guys remember what a rhombus was? Diamond? Well, can a square be a diamond? I know you guys are saying square, you're saying diamond, but what if I did this? I mean, isn't this, I know what you're saying, but isn't this, that's a square, right? Okay, what if, well, it's still a square, isn't it? Yeah. What makes a rhombus a rhombus? What about the eggs? They're not all the same. I see what you're saying. There's only, all right. So the rhombus, let me move this up here, has all sides congruent. Okay. The rhombus has all four sides that are the same. Okay, that's what you guys keep thinking about, in terms of the square, which the square does as well. Okay. But the rhombus, you have all four sides the same, but the other parts that are more specific is that the diagonals are perpendicular to each other, and the diagonals bisect what we call the base angles. Here's what I mean by base angles. Draw this now. Let's try that again.
Well then.
Yeah. This is, again, one of the reasons why I am not an artiste. This one should work. Yeah, that looks close enough. So you have all four sides that are the same. Okay. The diagonals are perpendicular to each other. So what happens is you get 4 right triangles in there. All right. Since it's still a parallelogram, remember, the diagonals still bisect each other, but they also become perpendicular. So it's that one extra little step to it. Okay. Since it's a parallelogram, opposite angles are still congruent, but these diagonals, what they do is they bisect the angles. So what I usually do is I draw this in here and here, and then here I do a double. And what that basically means is that let's say this whole angle, the big angle, is the base angle. The base angle are the angles of the actual parallelogram. Okay, the outer angles. That's what I mean by base angle. Does that make sense? So if I say this is rhombus ABCD, the base angles are ABCD. Okay? Does that clear up that one a little bit? Again, I know that you guys have all seen this. I know that you guys have all worked with this. When you see right triangles, gee, I wonder what's going to show up finding missing side lengths. Some crazy there that this old man did.
The Greek guy?
Greek guy, yeah, he's Greek. That probably ate a lot of euros. Maybe not.
Keep going.
Does she not know what a euro is?
No. She said, what is it? No, I know. Wait, say what it is.
Gyro.
Wait, say what it is so I know what it is.
A euro?
Yes. Say it.
You've never had you ever gone to Tom Jerry's and had a euro? That's Chapswood had one set of euros. Is that tzatziki sauce? Is it cucumber sauce? Anyway, I recommend, if you get a chance, at some point in your life, go to Tom and Jerry's and get a euro. They're really good. Like, really, really good. I'm not a fan of the tzatziki sauce. Yes.
No.
Okay, there you go. Not too terrible?
Not necessarily. No.
All right, let's look at the rectangle then.
But no.
Never a dull moment here, right, Mr. Hart? Never a dull moment. Rectangle. Rectangle still has opposite sides of the same, but what makes it more specific, all angles are the same. But in this case, when all angles are the same, it has 4 right angles.
Mr. Murphy.
Yes, Dan.
She said she thought Meryl was no, not dogs. What you just said? Dollars? It's still. Isn't it euro? Isn't that dollars?
You're thinking euro, E-U-R.
Yeah.
That's the euro is money.
That's what I thought.
Euro, it's oh jeez.
Moving on. Euro is like dollars. So I was just like that big. But you ain't saying euro, euro. I thought it was euro. Mr. Murphy, you know
Euro, this is the euro with the pita and the meat and the tomatoes.
Oh, I thought you were talking about money.
Euro is the money in the European Union.
Yeah, that's what I thought you were saying. That's what you selling. How are you eating? I'm sorry. I'm sorry.
So you were confused like why?
Don't give her. I was so confused. I was like, what? Okay.
So you're not wrong. You're just not right.
Wait, isn't that close?
Yes.
I wasn't wrong, I just wasn't.
Right. So now does it make sense?
Yes.
That is the symbol for the euro, right? The pound? Or is it have two? I think it might have 2. Just one? I'm very cultured. Anyway, what's that? That's the meat. I was trying. Anyway, so rectangles. Back to math. So the rectangles have the 4 right angles. And then the diagonals are congruent. The rectangle has congruent diagonals. There's a reason why that happens. Okay? And I think that's the only two that makes them specific, if I'm not mistaken. So when we have a rectangle, and again, I know you guys have all seen this shape because, I don't know, we're all at least of some certain age. So when you have the rectangle, obviously you've got the 4 right angles. We know that the opposite sides are congruent because it's a rectangle, right? Because it's also a parallelogram. Now, when I draw in the diagonals, the diagonals themselves have to be the same length. Here's the reason. If you look at it, can I slide this up a little bit just to show the picture here a little better?
You gotta do this.
I appreciate it. Actually, let's do this. I'll come back to it. What happens here? That didn't work. Oh, I didn't. I cloned it. Yep. There. Now. Now it works. So if you put your pencils down for a second here, and what I want you to see is if I highlight this, what kind of a triangle is that? It's a right triangle. Now, if the sides, let's say this is 6 and this is 8, what would you do to find that length? Pythagorean theorem, right? So if you do Pythagorean theorem, that gives you, now is that length there, that diagonal, is that a hypotenuse or a leg? The hypotenuse, because it's across from the right angle. So what's 6 squared? I'm trying to pick numbers easy here. What's 8 squared?
64.
64. 36 and 64 gets you to 100. What's the square root of 100? 10. Okay? So that length has to be 10. Now, it being a parallelogram, if this side is 6, what's this side have to be? 6. What's this side have to be? 8. So if I did that again here with the other triangle, again, it's still a right triangle, isn't it? Which makes that other diagonal the same amount. Oh, actually, the other way. If I go this way too, you get the same side lengths. You get the same diagonal. That's why the diagonals themselves always are going to be the same, because of the right angles and Pythagorean theorem. Okay? So again, you'll see we have some right angles. Pythagorean theorem shows up over and over again, but yet we don't define that in chapter 8. But whatever. Okay, so you'll be good at it by then, I hope. And of course, there's no tricks.
Right.
But that's why that works. That's why the diagonals themselves are always going to be equal. Okay? So far, so good. Again, this is nothing new. This is stuff you guys have all done. That should not be so bad.
One more shape in the family tree.
Yep.
Where?
It's going to have the characteristics of
Everything.
rectangles and the rhombus.
Oh my.
It's a square.
Otherwise known as square.
You're right.
See, Mrs. Robert? So the square, as you guys know, the square becomes the most specific of all the parallelograms.
I'm sorry.
Stop making mistakes. Now, the square has all characteristics of every one of them above.
Right on everything. Why?
Well, I don't know if you really need to write all that. What I usually do is I just make a diagram and I mark it. So the square The square has all four sides that are the same, 4 right angles, diagonals that are congruent, diagonals that are perpendicular, and diagonals that bisect. Angles that bisect. Okay. What happens here with the square just gets everything. It has all four sides are the same. All 4 right angles are base angles.
What y'all saying now? Man, circle is wrong. What you gonna do tomorrow? Huh? Your head's a circle. My head's not a circle. My head is okay.
Diagonals, perpendicular diagonals. One thing I want you guys to kind of notice, I filled it in. Each one of those base angles gets cut in half. What's half of 90? 45. So what happens is you get all these what are called 45, 45, 90 triangles going throughout the square. One of the other things you might notice is that this, let me highlight this a little bit differently. If I look at the individual triangle there, it's a right triangle, that one that's highlighted in blue. And it's also, notice that the two sides, the legs are the same. When you have two legs that are the same, it's called isosceles. You get a bunch of what are called isosceles right triangles in a square. Okay? For now, that's probably not anything you need to worry too much about. But if you know that one side length, for example, if I know that if this chunk here is 5, what's this side have to be? Which means this side is 5. The whole diagonal is 10, okay? Now, if you had to figure out the outer side length then, what would you have to do? Well, not doubling it. What kind of triangle is that? It's isosceles, but more specifically, it's a right triangle. Isn't that outer edge outside? It's the cross from the right angle. So you'd have to use Pythagorean theorem. So in this example, I say 5 squared plus 5 squared, we'll call it c squared because it's your hypotenuse. Now, this is where that multi-view calculator earns its money, earns its keep. What's 5 squared? So what's 25 plus 25? 50. So if I add those two together, I get 50. Now when I take the square root of 50, that calculator will give you the answer of 5 root 2. And that is the exact side lengths. Okay, going all the way around. Now, the multi-view calculator is going to become your best friend because we use those values in terms of what are called exact value. Exact value will have answers in terms of square roots. And then later on, as we get into later on in second semester, we'll have answers in what we call in terms of pi. That deals with circles and things like that. Okay? Not so bad? I hope. Okay. Excuse me. So you don't have to keep drawing pictures here. I've got a quick little sheet here to kind of help us use these examples. And I apologize. I apologize for getting the whole bunch of this. Now, this obviously isn't section 8.4 like it says on the sheet. I'm using this from an older text. But you guys get the idea here.
You're right.
Excuse me. So let's see, this is 8.4. So let's take a look here. And let's look at this middle chunk. Be able to classify what it is. Yes, sir. Sure. So I'm at this middle section here. And a lot of times what we'll ask you guys is, what's the shape and why? So as you start thinking about the family tree of the stuff that we have, number 5, you've got right angles in the middle. So which of the shapes have the right angles in the middle? It's either going to be rhombus or the square. All right. So the difference between the rhombus and the square is that the square has what kind of diagonals? They've got congruent diagonals. Are those two diagonals the same? No, which makes that a what? Rhombus. Exactly. Okay. Remember, the square is going to have congruent diagonals. In this case, it doesn't. Excuse me. If I go to the next one, since it's a parallelogram, you're given one right angle. If you have one right angle in a parallelogram, what do you know about all the other angles? The right angles. You're given one side is congruent to the next adjacent side. Well, since it's a parallelogram, doesn't that also mean opposite sides have to be the same? Opposite angles have to be the same. Consecutive has to be supplementary, which means that has to be a square. Okay. On 7, what is it going to be? Rectangle. Why do you have to say it's a rectangle and not a square? You can say that, but what I was getting at is that you don't have consecutive sides that are marked, like you do in 6, okay? What about 8? What's the best thing you do for 8? Why? Well, it could be a parallelogram, couldn't it? It could just be a plain parallelogram. What makes it more specific, though? When you're saying rhombus, what do you know about a parallelogram? What do you know about the sides? Opposite sides are congruent. So if this side has to be congruent to this side, which means this side is that side, so now if you've got all 4 sides, therefore it is the rhombus. It can't be the square because it doesn't have what? The right angles, yeah. The 90s. What about 9? What do you know there? What does it have to be? It could be, it's either a square, it's going to be a rectangle. Remember, squares and rectangles have congruent diagonals. What does it have to be? It has to be rectangle because it doesn't say anything about the outer sides. Okay? Since it doesn't have anything on there about the outer sides, there's nothing you can assume off of that. And then last but not least, what's 10 have to be? Square, good. That has to be a square because the diagonals are all the same and they're perpendicular. Okay? Let's look at another one. When you go through the algebra, first thing you have to decide here is, what shape is that going to be? Is that, you've got all 4 sides the same, so it means it's either going to be a square or a rhombus. What does it have to be? It's got to be a rhombus, correct. Why does it have to be a rhombus? Look at this angle here. That's not a right angle, is it? Nope, that means it's a rhombus. Okay. Now, with it being a rhombus, that means all the sides are the same, so solving for x is relatively easy. That means you have your 5x plus 6 is 8x. All right. Algebra here, again, nothing any crazier than what we've done. Subtract the 5x. And you get x is 2. Solving for y, on the other hand, might take an extra minute here. Now, it's a parallelogram, which means the opposite angles are the same. And consecutive angles always add up to equal how much? 180. Now, are those two angles, angle P and Q, opposite one another or next to one another? Next to. So that means that these two have to add up to equal 80. And then you solve it out that way. good. There's two ways you could have gone about doing that. If you know that the two angles have to be supplementary, and they gave you one of the angles right off the bat, can you just find the supplement of 97? You find the supplement of 97, you would have gotten, what was it, 83, I believe? And then that means that angle P has to equal 83, so you just solve for y, set it equal 83. That would work as well. Or if you just go with that same premise there, that's how they're set up to be okay. What shape does 12 have to be? Square, good. Now, oops, that didn't take. That'll work now. Yep. So that has to be a square. So you know solving for x is easy. They have to be equal. Because the check marks, that's also that giveaway. So solving for x is the easy part. So we have 2x plus 1 is 4x minus 7. Quick math, subtract the 2x, add the 7. And we get 4. Solving for y, though, takes a second longer. And this is why when we drew out our picture of the square, what did I write in for all the angles after they got bisected? 45s. And that's the idea here. It being a square means that the diagonals bisect the 90 degrees. So half of the 90 has to be top. And that's where this comes in. You get y is 6. Not too terrible?
No, because the right angle, I see why it is. I got you. So every time you see the right angle, you guys see that little point. You have 90 and then the answer right there.
Yeah, if it's a square, yes. If it's a rectangle, though, you can't do that. Right, because the rectangle, the diagonals don't bisect. Correct. Very, very good. Okay.
Gotcha.
All right, let's flip it over. Go through a couple of elements. This one was missing a couple of letters, I think, as you went through here. So it's W, X, Y, and Z. That didn't take again. Let's try this again. Remember that weird symbol that means angle? I don't know why sometimes the typeset does that, but it does. So first things first, it says it's a rhombus. And then it says the diagonals intersect at V. So V should be here. It being a rhombus means we have the 4 right angles. W, X, Y, and Z should go there. So from that, and having just that one angle, we can figure out everything. Remember, diagonals of a rhombus, they're perpendicular, and they just bisect each other. So if WV is 7, what's V, Y? 7, yep, there we go. Okay. All right. And now from there, let's see. We can figure out the angles. Remember, the diagonals bisect the base angles. So if one side here is 34, what's the other side have to be? 34. Now, here comes into play when we start worrying about it being a parallelogram. Opposite angles are always the same. So if the 2 down here are 34, the 2 up there have to also be 34. How many degrees are in a triangle? 180. So then to figure out the other angles, we start with the 180, back out the 90 degree because of the right angle, and then back out the 34. We do that, and I believe we should get 56. Did I do that right? Which means this spot here is 56, which means the other side is
56.
56. Right? There is a lot of numbers. Now, the one part on here that you cannot solve for, because we don't know how to yet, is the other edges. And that's okay. We're not worried about that in this unit.
Okay.
I wouldn't ask you to do that. I'd have to give you the other diagonal to make it work, because then you would just use Pythagorean theorem. That's about that would be the thing that we would give you guys. I'd have to give you 2 sides of the right triangle. No, there's a way to do it, but it involves using trigonometry. We just haven't learned it yet.
Okay.
All right, not too bad. Let's look at the other one. All right. Excuse me. Rectangle. PQRS, and they intersect at T, and they give you RPS at 62, and QS, the whole diagonal, at 18. So if the whole diagonal is 18 at QS, the other whole diagonal, PR, has to be how much? 18. Now remember, the diagonals get bisected always because they are a parallelogram, if they're called. So if the whole chunk is 18, what is each individual piece? 9. So I know that all 4 of these guys here are 9s. Okay. I also know that if I look at it, isn't this an isosceles triangle here?
Yes.
So if one base angle is 62, what's the other base angle? 62, good. So this has to be 62 here. Now, the other side isn't going to be 62. I know that for certain because it's a rectangle. What does that base angle S have to equal? 90. So to find the other side, I have to subtract it from 90. So take 62 and subtract 90. What do you get?
28.
28. And hey, look, isn't this another isosceles triangle here? If that base angle is 28, what's the other one have to be?
28.
Which means the other next side is 62. 62, 28, and 28. Now to get the angles around point T, well, how many degrees are in a triangle? 180.
True.
So if I take 180 and I back out 28 twice, 28 is what, 56? So I'll just do that. If I back out 56, I got 124 for right here, which means on the other side is 124 because those two are what kind of angles? Vertical. And then to get the other sides, you just find their supplement.
So you say 180 minus 124.
Gee, what is 180 minus 124 going to be? Boy, that's convenient. Oops. Look at that. It's 56. And again, from there, there's really nothing else. ST we got. PR we got. Yep.
What's the M and the
It just means angle. Sometimes the old worksheets they printed it like that for some reason. I don't know. It's just another way of writing angle. I usually use the way that I do it. Okay. And then I think the last one is the square, and that one's really quick. You're all right. You're all right. And lastly, the square one is the quickest. So if you've got one chunk of the diagonal at 15, what is every other chunk of the diagonal going to be? 15. It means all these guys are 15s. What is each angle in the corner going to be?
90.
Which means when it's bisected, they're always, and so on and so on. Going from there, it's really easy. I don't think they're making you find any of the outer spots. In a square, you could figure out the outer spot because that's just a right triangle. You guys can go through that relatively easily. Let me see here. Yeah.
You know what? I think it's nice. Like that, you got couch day.
That did.
Thank you very much.
So on this one, sorry, let me get these out real quick. On this one here. So it's 8-4. It says 8-4, but it's technically not section chapter 8. We'll do 5 through 12. And then, actually, just do 5 through 24. All right? And they should be a really, really straightforward. I don't think, yeah. Because on the other side are just like the examples we just did in class. I think there's one on the other side that you can't do. No, you're good with that one, you're good with that one. Yeah, you can't do 16 on the other side. The rest of them should be all right, I think. If you come across one that doesn't make any sense, it's probably the one you can't do, so it's okay. All right? So this goes 5 to 24. It shouldn't take very long. We'll probably go through a couple of the extras of these tomorrow as well. We'll go from there. Okay?